Do you think that a 5-liter engine performs better than a 1.8-liter engine? Things are not so simple. In this high-tech age, it would be a mistake to consider only one parameter when establishing the overall performance of a car. Compared to the 60s, when engine displacement was the be-all and end-all, today car manufacturers recognize there are many parameters that truly distinguish one car from the next. Well, it's the same for building insulation products. In the 60s, it was believed that thermal conductivity and thickness were sufficient to characterize the efficiency of an insulation product. The thicker the insulation, the better it was. In actual fact, as we've just seen for cars, many parameters contribute to the overall thermal efficiency of an insulation product. 2 devices were developed in the 60s and designed initially for testing traditional thick insulation. These are the guarded hot box and guarded hot plate. These 2 devices measure RT, the thermal resistance of an insulant, according to current standards. RT is the thermal resistance of a material defined on the basis of its thickness and the thermal conductivity of the material. The thermal conductivity of the material is measured by applying a temperature gradient between the insulation faces and measuring the heat flux across the material. This measurement only takes into account the temperature difference between each insulation face, the insulation being in a steady state, i.e. in a constant temperature environment. The sample to be tested is first placed in a heat chamber to remove any traces of moisture. It's then placed in an environment free from air movement, humidity variations, and solar radiation. In short, such an environment differs substantially with actual conditions, and yet this is the basis on which insulation products installed in buildings are still officially assessed today. In reality, insulation products are simultaneously subjected to temperature variations, the wind, differences in pressure, solar radiation, and night sky radiation. Such conditions are nowhere near the steady state of the guarded hot box. Actis has been testing its products in real conditions for 20 years. Thanks to this exclusive method, the thermal values advertised take into account the actual efficiency of the insulation once installed. Actis constructed several buildings on the same site, facing the same direction. The only difference between the buildings was the insulation. One building was fitted with 200mm thick glass wool insulation with a thermal performance known and certified according to current standards. The other building was fitted with a thin, multi-layered insulation product for which Actis was seeking to determine and evaluate the thermal properties. To carry out the research program, Actis developed a testing protocol that covered 5 areas. 1. Choice of testing site. 2. Construction of test cells. 3. Calibration of test cells. 4. Installation of the system to be tested. And 5. Acquisition of more than 8 million data samples per week. The aim of the approach was to measure the amount of energy needed to maintain identical and constant temperatures inside both buildings, whatever the weather. The measurements obtained during in-situ testing carried out throughout Europe demonstrated that laboratory measurements greatly underestimated the performance of multi-layered insulation, and this was therefore not a true representation of the energy usage of buildings insulated with such products. We have proved, therefore, that the energy consumptions of the buildings insulated with traditional insulation and those insulated with Actis thin insulation are almost identical, but with a thickness factor of 1 to 10, not to mention the other benefits such as durability, air and water tightness, and water vapor resistance. This is a far cry from the laboratory guarded hotbox tests. A good insulation product responds to all the weather parameters which could have an impact on its performance. Actis products installed according to Actis guidelines are simultaneously effective against all types of heat loss. Unlike traditional thick insulation, which is mainly effective against conduction heat loss, because of their specific nature and because they're installed with an air gap on either side, thin reflective multi-layered insulants act like a barrier to the passage of heat by working principally on the reflection of radiation rather than on conduction or convection. The external reflective films of Actis insulation reflect infrared radiation very effectively back towards the emission source. Heating in winter, solar radiation in summer. Inside the multi-layer insulation, each internal reflective film provides an additional barrier to the transfer of heat by radiation. Because the insulation is installed between two air gaps, i.e. without contact with the wall, floor or roof to be insulated, the transfer of energy by conduction is considerably reduced. The various components also create many small insulating air layers, again acting as a barrier to conduction. Finally, the external reflective films are air and watertight. Because of this, the insulation stops cold air infiltration in winter and warm air infiltration by reducing convection.
Our duty is to comply with the Kyoto Protocol. This is essential. The current standard, which takes into account only thermal resistance, is not sufficient to meet the commitments arising from Kyoto. What we should be assessing is the actual efficiency of insulation in real conditions. That is our objective, that the manufacturers of thick and thin insulation put our heads together to draw up a new standard.